When a hydrocarbon chain is cyclic, we call this a cycloalkane. Here's an example right here. Cycloalkanes follow the same basic naming protocol as other alkanes. If the cyclic part of the molecule is the parent hydrocarbon chain, then the prefix cyclo goes in front of the last name indicating the number of carbons. If, on the other hand, the cyclic part of the molecule is not the longest part and it comes off as a substituent, then the prefix cyclo goes in front of the name of the substituent. I'll show you an example of that in a moment. So let's name this thing here. First, again, as always, we number the carbons to see what the longest chain is, and we see here that the cyclic part of the molecule is in fact the longest part of the molecule. Now, obviously a circle has no end and no beginning. So we always number a cyclic molecule so that number 1 is assigned to one of the groups if there are groups that are substituents coming off of it. And again, we number it so that the groups together get the lowest possible numbers. So the lowest numbers I could give this one are 1 and 2, clearly. So the question we want to ask now is, which of these substituents is going to get the 1 and which is going to get the 2? So if it's a tie in both directions, and in this case it is, it's a 1 or a 2 or a 1 or a 2, then we're going to give the first listed alphabetically substituent the lower number. Here we have a substituent we can name two ways. You can use the prefixes from the table that we studied earlier, and from that table we know that this is an isopropyl group. Or we can name it in correct IUPAC nomenclature. Either one is acceptable for this class. Let's look at it as isopropyl first. So we don't ignore substituent prefixes like iso when we're alphabetizing substituents. So iso comes before methyl. So then that makes this molecule 1 isopropyl, 2 methyl cyclohexane. Now, if we're going to label this substituent systemically, we're going to start by labeling the carbon attached to the parent hydrocarbon, starting at the parent hydrocarbon with 1. You find the longest chain side group. This is the new group's last name. The smaller group attached to it is its substituent and gets a number indicating where it's attached to the side chain, using the carbon attached to the parent chain as carbon 1. This numbering is included within parentheses to indicate that they only refer to substituent numbering of the biggest substituent coming off the parent chain and don't refer to where on the parent chain the substituent group branches from. The number indicating where the substituent comes off the parent is still included, but that goes all the way in front of the substituent outside the parentheses. Now let's name this alkane. We see here that the ring has 6 carbons in it, while the straight chain here has 8 carbons. So now the cyclic part of the molecule becomes a substituent. So 1, 2, 3, 4, 5, 6, 7, 8 carbons, that gives us an octane. And the substituent can come off at either carbon 3 or carbon 6. Clearly carbon 3 is smaller, so 3 cyclohexyl, because it is a 6-carbon cyclic substituent, octane. That is the correct name for this molecule.